So, without further ado, I would like to invite Professor Jean-Pierre Ometto, or just Jean, Jean Ometto. He's a senior researcher at the National Institute of Space Research, INPE, where we're going to visit this Friday. And the head of the Strategic Project Division, a member of the graduate program on Earth System Science there. Jean has a long CV, and you can read his profile for most of that, but just to pick up that he has been involved with IPCC, IPBS, IAI, and several other international organizations. It's a pleasure to have him here to talk about climate change and biodiversity loss, the challenge of complexity. And please, Jean, the floor is yours. Thank you so much. He has a very busy agenda, so I'm really grateful that he could find space and come to give his talk. Thank you.
Thank you. Well, no. Okay, so I'm just going to have this running here so I don't lose myself here. So I would really like to thank you a lot, Chris and Chris, Ju and Alice, for the invitation to be here today. I was sort of part of the first conversations of this school, and thought it could be a really interesting opportunity to interact in this such complex thematic and environment. I think I work at the National Institute for Space Research, but I've been associated to a center which was called the Earth System Science Center, which was one of the first initiatives in the country, sort of, that to bring this to the, so INPE is a federal institution, so to bring this connect to the Ministry of Science and Technology, which the INPE is part of. So Brazil has several of these research institutes that it's associated to the Ministry of Science and Technology. So I think that was a very important and interesting step for the Institute to come from space science, more of a hard science, to I don't think we got to the transdisciplinarity thus far because of all the complexity of this, but we're doing multidisciplinary work, and on Friday we're going to be able to see a little bit of this, especially working on in Brazil itself with local communities, with indicators and different branches of the government. So it's a big honor to be here. Thanks a lot again. So what I'm going to try to do a little bit is to navigate. So we, most of us, I would say, we generate science, we generate information. And how this dialogue with the world outside our universe. So I think that's the big challenge that we face, and how that is being relevant for decision making. How the work is dialogues with other contexts to a specific decision to be taken. So, oops, I need this. So, if I turn to the right side, that might work. Okay. So who said that the planetary is under a crisis? So where that information came from? So we have a statement from the Climate Convention saying that, okay, we are under a crisis that are basically associated to climate change, to biodiversity loss, and to pollution. So how science was part of this understanding that the planet is at risk or is under a crisis. So that's is the question of dialogue a lot. And if we look on the solution part of the crisis, so how we can solve. So crises are something that are made to transform in such perspective, or to, decisions being taken. So, as we're going to see in the information that science is being providing to the other societal context, from civil society to governments to, to establish a convention. We know that, the climate convention was suggested or established in early 90s because of an event that happened, Rio 92, as most of you know. On the track of that, the biological convention came out too. The desertification convention came out too. So how we dialogue with all that? So we know that these bodies, they ask for the scientific community through assessments like IPCC, IPBES, and Global Environment Outlook. So it requires from the scientific community information. But what sort of information, how the information get there, for the decision being taken. And as we're seeing, and we're gonna, see a little bit more, it seems like that we're sort of in this Jevons paradox, which is probably most of you know, which is it's a wrong direction. It's not 1985, it's 1885. But so this British economist said, okay, the increases of efficiency of using resource will lead to a potential decrease of the use of that resource because of the efficiency of using that. And as we're seeing, and that's what is the paradox about, is that we're not decreasing the use of resource, by the opposite, in fact. And a lot of this, we are basing the decisions over climate change, even biological diversity, or other pollution, on technological solutions, and looking very little to change behavior in institution. So, and this, I think, for us here, I think is part of the journey that, that Chris mentioned at the very beginning, this transformative learning journey, transformative exchanging journey, that we have to take as planet. And to my perspective, science has a big role to play on this. As we're going to see, science is not the only aspect for a decision to be taken or to be thought about, but it's an important one, because it raises problems that most of the times, or sometimes, the decision maker don't see. Okay, so when we go to a political definition of a specific process, that comes from the UN. So you see that, climate change refers to long-term patterns, shifting temperature and weather, long-term shift in temperature and weather patterns that in the long run will completely alter ecosystems that support the life on the planet. So this is a basic, we see the science has support this in some perspective. But what is this long run? What we're talking about? How much the urgency is expressed in this statement. And the urgency is right here, as we know. So we've seen this a lot. This was the volume of IPCC that I contributed. But we've seen this. So all these changes that science is providing by generating data. We have tons of data. We have data from A to Z in abundance. What we need more? We need more data. We need more transformative actions. We need more changing behavior. How this actually comes together with a perspective like that. So we're seeing this, it's here. We're seeing this as a diagnostics. So that's the pattern that we've been observing the past 20 years. I think it's kind of blurred, but on the on the PowerPoint there, I think is good. But on the past 20, 30, 50 years, what is the pattern we're seeing? So the pattern we're seeing, it's the data that we're acquiring. Globe-wide, from oceans to atmosphere to terrestrial systems. So we're mapping this. And we're being able to go back a little bit. In this case, 500 years. In ice cores, 800,000 years, even a little bit more. So we've been able to map on the past. But very few decisions are taken mapping the past, which is not good as well, because history is absolutely central for changing behavior or to understand patterns. So, and this was just last year. You've probably seen this. So this is, we know, changing in atmosphere, concentration of greenhouse gas components. We see the patterns of temperature change associated to that. Yeah? And on the long-term changing that we saw on the first statement there, where this is going. So how can we decide something in terms of the past? So that's one point. How can we look to the future and say, all right, so the changes need to be made because we're following this path. And here we're seeing that we're really taking a while to take decisions on this. So the patterns are going to a direction that we're going to have, we're already having, but we're going to increase the change in the planet physical behavior, which we know that this is all connected to biology and it's all connected to society. So we're talking about 1.5. We know of the Paris Agreement said, okay, let's try to be in a safe side of this. What is the safe side of this? So then the politicians say, okay, IPCC, what is the safe side of this thing? Where we can go? And then the science comes together and say, okay, so we can go from 1.5 to 2, but don't get to 2. Let's stay 1.5. And then, okay, let's make an agreement of this. So that Paris Agreement comes out to 2015. And I think that there's changes on the way and changes happening, but they're probably slower than they should. And then we need to look to the future. We've seen this as well. This comes from the synthesis report. So the IPCC this time, what they did was they got the whole 3 groups of information that were gathered. Group 1, which is the physics. Group 2, which is adaptation, vulnerability. And Group 3, which is mitigation. And plus the special report. There was a special report on ocean, special report on 1.5. And got this to a synthesis report, trying to convey the information. I don't know if you were familiar with IPCC entire report. So that's a lot of pages. And no one reads them. Not even the ones that write that thing. But because you read what you wrote, but the rest you kind of take a look. So, but this synthesis, okay, so the patterns of change in the planet are this. But we're still talking a planet perspective. But if we don't, any change in temperature can make a big difference. So if we curb the change in temperature a little bit, we can reduce the level of risk. And we're not, probably today, I'm not going to get there, but we're going to talk a little bit about adaptation Friday, I think. And we're going to see, so when we need to decide to what we adapt, what are the elements of the system that are vulnerable, we need at least a fair projection of what's going to happen. But this is still very coarse. We're looking to the global. And a lot of this here is going to be more into the global side. Okay, so second point of our planetary crisis. So again, what biodiversity loss means by the politicians refers to decline and disappearance of biological diversity, which includes animal, plants, and ecosystems. Okay, so we're reducing that. What is the rate that we're reducing? How bad that is? And the perception that biodiversity is the base of everything is there, and the perception of what the laws would imply is there as well. But, you know, so how much? How we can, so this is an interesting IPCC, IPBES report that tried to connect biodiversity not only to climate, which is one of these drivers here, but to the whole functioning of the global society in this perspective, how we deal with that. And what comes out from that is a little bit of how the ecosystem can adapt. What is the capacity of the ecosystem and the social-ecological systems, which is fairly new in this perspective. The reading of the social science of the importance of the relation to nature is old, is more mature than it is within the climate world. Not into the biodiversity, not that much, because the connection, one of the matrix behind IPBES is the nature's contribution to people. So this is embedded in this perception at the global scale. But still, the decisions are not being taken. They are being taken, but not that much. So, but we have numbers that are dramatic. So we lost about 900 species that we could map in the past 500 years. And we don't have this curve here that, you know, what is the rate of loss in the past 100 years, which is most of this happen. So we do have those numbers. We do have the risk of different species to be affected by different processes from climate change itself, from change on land use, from change on perspective, demand of resource, as we saw in the beginning. So all this data, it's out there. This information is out there. And we can project that. So there's a work by Luciano that works in the Federal University of the Amazon. And so what he did, he said, okay, what is the projected resilience of an ecosystem, not talking to species now, but of ecosystem, under projection of climate change? Can we talk, and this was part of the Brazilian national communication for the climate convention. So can we talk to decision makers, say, okay, we need to do something, because we're losing just because of changing climate. And this is dramatic for several processes. This feedback, the climate change itself, and the major aspects, laws of ecosystem functions, laws of biodiversity, laws of ecosystem service, and people that depend on those systems have their lives compromised. So those are projections that have one thing that normally is very hard to convey to whoever takes the decisions, which is uncertainty. So how we can think on the uncertainty in a way that is being perceived. Sorry. So, and this is another huge issue. So when we're talking about pollution, and we're going to talk a little bit, an example of stakeholder relation to science on chemical industries. So pollution is the large cause of disease and premature death in the world. There's something here, there's something here that I don't know what it is, but it's from the United Nations. I cannot read. maybe, yeah, yeah, maybe you can read, because you know what is there?
So 9 out of 10 people worldwide breathe air that contains levels of pollutants that exceed WHO guidelines.
Thank you, thank you. Yeah, so that's what is there. So, and that's an information that comes from the UN. And this sort of information is, okay, so 9 out of 10 people, that's basic the whole planet. Probably not who lives here in São Luís do Paraitinga, but and other aspects, water pollution and soil pollution and thus forth. So this aspect here is being mapped. And but do we have global data of that? We do have. We do have global data, and we know this level of 2 million tons of wastewater being dumped in freshwater systems every year. So we do have this information. The distribution in several countries, and the dramatic part of this is that most of this impact affect, which happens to climate change as well, affect less favored people, less favored communities. So the inequality in terms of the societal inequality, it's awful in terms of impacts of pollutant and climate change. Okay, so how we can think about this? So we have let's say a co-interaction of socio-ecological systems. We know that at different scale. So this is absolute central. Someone in the first talk by Carlos Greff talk about how community can access funds, for instance. So these socio-ecological systems, the scale of this is absolute central. How we can bring a co-beneficial aspect between climate, biodiversity, and people. How this plays together. How we can have actions on the ground to make that happen. Instead of having trade-offs, that's probably some required options. Sometimes we need trade-offs. So, not a fair example, but sometimes if we produce food, we need the soil for that. And we need to take out whatever's on the soil. Not to the rate we have today, but at the perspective of the trade-offs. So, and this can be a bit more harmful to people or to biodiversity or to climate. How we balance those things. And or it can be the way we are today, in a sense, that is co-detrimental. So that can be. It could be co-detrimental. If we have large-scale commodity agriculture, it can be detrimental in terms of climate, in terms of biodiversity, in terms of people, for resource distribution. But how we move this system to here and eventually to there. So it's a question for us. Why environmental research is not instrumental as it should, or contribute more substantially to environmental problem solving? We've been generating a lot of data. We're doing a lot of things. We've been working on environmental research, from ecology 100 years ago to this connection of environment, 40, 50 years ago. So what is the point that our speech, and when I say this, please think this in a general term. It's not specific for some, probably we know that there's a lot of things going on. But when we look to the previous slides in terms of how data is showing us how the planetary crisis is worsening, so what is the point? One aspect is that the increase of scientific specialization, disciplinary specialization. So as a community, again, please, we one beautiful thing of an exercise and an event as we have here is that we have the opportunity to work together with different disciplines. And that's, I think that's the transformative journey that Chris is mentioning about. So the point is that how we, and this has happened in several schools. So disciplines got very specialized and very precise in terms of data. So we know exactly what the photosynthesis of the leaf that is on the top right part of that tree. Well, at least we know how to measure. As we know how to, think on population dynamic of a specific species. And this sort of a fragmentation in terms of disciplines. And it's interesting. Just making a little parallel to what Graef said this morning, someone rose this issue too. So part of the interdisciplinary funding of FAPESP, it doesn't go over 10%. And we know that because I'm from the climate change program of FAPESP, and most of the projects that are interdisciplinary are all from BIOTA, which is a biodiverse funding a project scheme in FAPESP, or from the climate change. So, but this fragmentation prevent the disciplinary research to tackle real-world problems. Real-world under brackets because it kind of became a buzzword that if we don't work with real-world, we do. But the point is that what is the problem that is down at the bottom that needs to be solved? In fact, to define the problem is another big issue. So that's the fragmentation as well. It brought us to produce a lot of data and how this data dialogue with the decision. So I think that, it became bizarre. This should be all in one. That's the, talking about technology, that's the Apple with the PC disconnection, But anyway, so this is basically a definition of what is transdisciplinary research, which is not a joint of disciplinary that sit and try to solve a problem. So we have the disciplinary perspective of a specific problem. We can come from this to the multidisciplinary, to the interdisciplinary, and to the transdisciplinary. And the transdisciplinary, in fact, it should be a co-construction of a specific strategy to deal with a problem on the ground. And why the research is on the base of this? Because we need methods. We need scientific, robust methods to dialogue in a transdisciplinary context to move on with that perspective. So, these societal challenges, the scientific rigors, societal relevance, those aspects are central for our community as scientists, but to bring the methodology, to bring the, yes? Oh, sorry, I thought it was it was a stretching, yeah. Okay. So, yeah. Okay, so that's, so how we dialogue within this universe. So I think that's the opportunity, and I bet a lot of you do something like that, but how we dialogue within this thing, this universe of discipline to meet a challenge and to solve problems. Yeah, so this kind of a unformatted too, but this is it's a paper by Marcel Bursing. He's a colleague that was from CDS at Brasilia, and the points are, so exactly what we're talking about. So to address complex, real-world global challenge requires integrated academic work in university and research centers. So so we're talking about global challenges. So the idea was to talk about global challenges. But we know that the real world solutions, the real world need and actions are at the specific location, you know, at the ground, the specific location. Yeah, so, and a key aspect of this, how we interact with stakeholders. The mantra of interacting with stakeholders needs to be thought through. And why that? Because sometimes interaction of stakeholders, and depending on the stakeholders, can be detrimental. And we know that. How the science community can identify this, excuse the word, these traps in terms of falling into a specific context of chemical industry, as I mentioned before. So what are the elements that bring stakeholders that, you know, will cope with the science to solve a problem? So that's the mapping of stakeholders is absolutely central. And it's part of the scientific community, sort of, because the identification of the problem has to be a co-identification. We cannot come with a problem with some in a table, say, okay, we have this problem we need to solve. This is a co-construction as well. But this mapping, it's possible to be done when it's done from the very beginning. Yeah. Oh, this came out. So this is, it's a nice statement by Manfred Steger, and so, which I thought was interesting. So transgressing disciplinary space means establishing relationships to knowledge that are more open to the perpetual intellectual demand for change and self-alteration. This is a bit complex, but that's the base of it. How we can scientifically think on this to the information that we produce be important for the transformation actions. And in the global studies, which a little bit Marcel talks a little bit about too, must stretch beyond the confines of convention-bounded concepts like society or nations in the global studies. We cannot solve a problem which is, you know, thinking on boundaries. And this thinking is not trivial, because the perception of nations, the perception of geographic cuts, the ownership of that specific space sometimes is difficult to go over, specifically in those sort of thematic. Okay, so can we come out with some criteria for this transdisciplinary research? First aspect, I would say, is problem orientation. So it's not saying here that basic science is not important anymore, that we have enough data, we just have to work through that. And a parenthesis is this. Some synthesis centers that we know of that are around are doing a great job working with the data that the community has produced, looking to the solution space. So and have the questions derived from the solution, as I mentioned, solution space, to the real world questions and problems. So we do have the real world questions and problems. We talked about those three planetary crises, how that actually talk with them. And then the clear definition of the problem is essential, and that's where the co-production is central. So if we go out here, say, what is the climate problem that we have in this part of the world that we're looking at? So it's because we have, you know, intense rain, we have lower rain. What is the way of going around this? Can we use data from, I don't know, from Indonesia to work here, because, you know, it's kind of a subtropic region here, or not? So the clear definition of the problem is essential. And then the scientific method. We know so a lot of countries has going through what was called national determined contribution. So on the targets, okay, so we need to reduce emissions. All right. So what are we going to do? We're going to reduce emissions. Oh, all right. So what is the strategy to do that? Okay, so I have my strategy shown on the what I first call intent national contribution. Intent determined national contribution. And that become a national contribution. And that was saying, okay, so we're going to reduce the emissions of Brazil to certain percent based on these activities here. So where did that come from? It comes from a general perception. If we have stakeholders at that level that dialogue with the community, you say, okay, so we have a sort of a connection here that allows to say, okay, so you can, reduce deforestation. That will help a lot. Okay, so that's the data. So to reduce deforestation, what I need to do, what the implication beyond carbon that are all there on reducing deforestation. So these informations give the strength, it gives the basis for potentially a stakeholder taking a decision. Well, dialogue. So the dialogue between disciplines it does not replace transdisciplinary approach. And you're certainly going to be exposed to this throughout those 10 next days. So we can talk to different disciplines. We do that quite often. But that doesn't really replace transdisciplinary in the perspective of the problem, the solution, in the perspective of the co-production, in the perspective of the co-thinking of that perspective. Okay, so, this kind of it's not very good. It's just bringing some, okay, so there's a lot of blah, 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 it's interesting. So can we finance those sort of things? Can we talk, FAPESP, Graf talk about FAPESP a lot, and how we can provide means to the scientific community to actually look to this perspective from their side, from this community side, and looking to engaging different sectors. So this Bellman, which is a funding scheme that exactly aims to support international transdisciplinary research, providing knowledge for understanding, mitigating, and adapting to global environmental change. So the idea of this, so we see, it was something proposed by funding agencies. So okay, so and this was 15 years ago, maybe Lila can help me, or something like that, 15 to 20 years ago. So this perspective of the need of a transdisciplinary research in the different, in the whole different thematic of the planet, I would say, from atmosphere to ocean to biodiversity to people to to agriculture to production systems and thus far. So how we can bring, how we can finance. So this is an opportunity. So take a look on this. I'm going to give a little example if that comes out of what we did on that. And the Bellman Forum is distributed. It's not an advertise for Bellman Forum. It's just that it's something that is out there that you might consider throughout working this week, look into this and say, okay, can we, at our universe, build a consortia among 3-4 countries to look to a specific problem that is being funded by this initiative. And one aspect that is central to this is communication. And the whole construction of transdisciplinary that social science brought, the reading, the perception, and the way of understanding society to this context is absolutely central. But social science, but also the communication. How this interact to different people, how this interact into different communities, how we can use the information we have and interact at different levels of stakeholders. And part of this, it's a lot of giving back. In Portuguese is devolutiva. I don't know what is in English, but anyway, it's when you work with a community, and then when you have your results, you go back and share, and what your analysis is showing. So this is quite relevant. So this is an example of something that we did. And so that was it's not a lot of biodiversity here, but yes. So it's it was led by Shin in the U.S., and so there was a group of five countries on this perspective. It was anyway, it was U.S., Germany, us, Brazil, and Turkey, and South Africa. So and then we said, okay, look into this. I mentioned something about what to adapt to, what do we need to do in terms of the complexity of the environment. We're not dealing with that leaf anymore. We lead to the whole complexity of the interaction of climate, leaf, people, biodiversity, and thus forth. So this is the idea is how we build. What's the metrics? What is the matrix and the metrics that we build to say, okay, so those elements are improving or not. So we need indicators. We need, and indicators are very useful for decision making as well. So you can show how the indicators are changing with the actions that are being taken. So that was basically what we did for this work, and that was funded by Belmont. So FAPESP is part of Belmont. So FAPESP fund the team in Brazil. There's others today that's funding that, and the individual funding agents from different countries fund the research community there. But the question is there, out of a specific set of indicators that you come out with it. Well, I understand this. I'll do that. Leave to me the indicators, I come with the list. So you do that. You're a researcher, you understand that aspect. Okay, so and you look from water, land use changing, land laws, and land use change and biodiversity, climate change, agricultural labor productivity, and availability of credit, agricultural support, and we go food laws, food security, and we go from all those systems. I'm going to trap the biodiversity down here very soon. Health, but we don't know all this. We cannot come with all this set of indicators. So we need multidisciplinary, and we need to bring people that say, okay, is this valid within the production context of agriculture? And so we did for a lot of countries. In Turkey, is it valid? What are the elements here? Are you still changing the use of land? Because here we are. We are deforesting as crazy. When we stop deforesting the Amazon, we start deforesting the Cerrado. When we stop deforesting the Cerrado, we go back to the Amazon. So we love to deforest. And we love to put fire in the systems. But so you need to validate, so you need to validate that in some perspective. So you can come with, part of the cake that you're going to build. But you need other parts of the recipe. Sometimes someone can come with a new idea. So let's change a little bit of cake. So, you need to interact to people in that perspective. Being the community that you're interacting at a local scale, being a broader community that you try to say, okay, so can we have a global matrix of expansion of biofuel? We want to get rid of oil. So, okay, we're going to get rid of oil, of petroleum, so how are we going to do that? And then you stock, so you get feedback from the community, and then you rebalance the indicators, which are more important for a specific region, might not be important for the other regions. So this dialogue, not only the solution, but the dialogue to the expectation of changing, of transformation, it's very important. So I think that was the last one. And so that was the idea. It was kind of a rushy, But the idea was to go over this perspective of how important is what you're going to do this next 10 days. Thank you very much. Those are the funders here that Chris already showed. And this is a goodbye slide. Thank you.